It's time for the remainder theorem. All right, remainder theorem, nice and easy. All it says is if we have a function, we'll call it f of x, and we divide it simply by a linear term, there's a linear term right there, then the remainder is the same as if we take the opposite of the value in the linear term. So this is minus b. If we put a positive b into the original function, the remainder is the same as this calculation. Let's look at it on Desmos and through some division so it makes a little bit more sense. So let's take 3x squared plus 8x minus 4, and we're going to divide it by x minus 2. And if the remainder theorem holds, all we really have to do is, since we're divided by a linear term, which is x minus 2, all we need to do is find the value of x equals to 2 in the function 3x squared plus 8x minus 4. And if that is the case, then that should give us the remainder. However, let's do the division and then let's check it on Desmos. All right, so I set up our table in the area model, 3x squared plus 8x minus 4 divided by x minus 2. And remember, when we divide this, and we're going to slide in that 3x squared, and then we're going to say, okay, well, x times what is 3x squared? Well, that is 3x. And then I'm going to bring that 3x down, 3x times negative 2, which is negative 6x. At that point, I'm going to say, well, what do I add to negative 6x to get this 8x? Okay, or I could write it, if I need to do some algebra, I could say 8 equals to negative 6 plus what? Well, that is 14x. And then I say, okay, what did I multiply x by to get 14x? Well, that is 14. And then I say 14 times negative 2, which is negative 28. And then once again, I say, well, these are not the same. So that means there must be a remainder. And I have to find out what plus negative 28 is equal to negative 4. And I could write that down as some algebra too if I needed to. Negative 4 equals to negative 28 plus some value and add the 28 over. It's going to give us 24. Okay, and our remainder is 24. Well, now let's check using the remainder theorem. Okay, and what the remainder theorem said again is if I divide a polynomial by a linear term, x minus 2, all I need to do is flip this guy and then plug it in to that. So let's go ahead and check that on Desmos to make sure that it works. Okay, so I'm going to come over here. I'm going to type in 3x squared plus 8x minus 4. And guess what? I've already got that. Okay. And I'm going to type in f of positive 2. F of positive 2. I've plugged the 2 into the equation. And guess what? It gives me 24. There's another way we can do this too. I can type in x equals 2. And when I type that in, what we can do is we can look for that intersection. And if we look for that intersection right up here, we'll see again that, hey, there it is right there. There's that value, x equals to 2, and that gives us a remainder of 24. And what that tells us is that factor that binomial of x minus 2, this guy is not a factor, not a factor. And that's really important to remember. Remember, a remainder of 0 is the only way it is considered a factor.